So, hello students. It's been a gap of about 10 to 12 days due to some unavoidable personal reasons. I couldn't conduct the classes. So, as far as I know, we have finished. We finished electric field. Okay, whatever the concept we required, we had already finished them in the previous classes up until previous classes. So today we shall be starting a new topic, and also you do problems for electric field. You keep practicing electric field, and if any doubt arises, you can comment uh, in the videos, and I have dropped or I have given my contact details. You can also contact there. So, and if you need any other help, like help regarding problems and numericals, so you can also contact me there. You will always get a good response. So today let us start a new topic. So we have finished electric field, and now is the time to learn about electric potential. Okay, learn about electric potential. Electric potential. So leave this word. Okay, leave this word for now. Leave electric potential for now. No, so leave electric, the word electric for now. Just focus on this term, that is potential. You already know. Okay, you already know what is a potential. Okay, so from class 11, even in class 10, you have heard about the potential, but it has another term mentioned with it, that is potential energy. Okay, from class 10th and 11th you have known that potential energy is associated, has been associated with another term, that is gravitational potential energy, because in class 11th you have learned about gravity and gravitational motion, and you have learned it in class 10 also. So you have learned about gravitational potential and gravitational potential energy. So what is a potential? First of all, let us understand what is a potential. In order to give a body an acceleration, you need a force. Okay, from Newton's law, you know that in order to give a body an acceleration, you need a force. You need a force acting to be acting on it. So in this case also, we are going to learn about these things. So if it is an water object, it is an object. See this thing, a very similar thing. This is, you have seen this. Okay, so see, this is a stopcock. You know what is a stopcock. And water level, this container contains water. Okay, this container contains water. This is a narrow region, it is a thicker region. Okay, so it contains water up to this mark, up to this mark. Let me lower that mark. Up to this mark, let us consider that up to this mark. Okay, once, now can you predict what happens when we open that stopcock? Can you predict that? Now what we do, we open that stopcock. So water starts to flow from here to here. Water starts to flow from here to here. But up to how much level? That's the question. Water will flow from this place to this place, but up to how much time, or what is the level that water starts flowing from this point to this point and then stops? So it is a quite an easy answer, because you have seen these many things in daily lives. If you have ever gone to any construction sites in your locality, you will see that many you have seen many masons, those who lay bricks, they need to level up the bricks according to sea level. They need to level up the bricks such that it is parallel to sea level. That means, and for that they use this technique. they use this technique. So what is this technique? So we don't want to talk about the technique, but just know this technique, that water will flow from this side to this side up until the water level on both sides becomes the same, irrespective of their volume. Okay, irrespective of their volume, the water level goes same, and this flow stops. This flow stops, or this flow occurs until the water level do not become equal. This level is not achieved, or the same height is not achieved in both ways. So that's why we use sea level in every height thing. Whenever we shall be asking about the height of a mountain or anything else like that, like these things, we are also mentioning the sea level in that, because sea level is same throughout. In this case also in the construction cases. So this flow occurs due to potential. This flow occurs due to potential. It was at higher potential and it was at lower potential. So object flowed from higher potential to lower potential. Okay. So you can actually see. So object can flow from higher potential to lower potential. So you might be getting some idea about potential. Okay. So we shall be discussing more about this potential. So I assume that you have understood this thing, that objects can only flow if there is a difference in the potential. So see this thing, I am saying about a difference now, mark my words. Okay. So it has something of a potential, it has something of a potential, that is also called potential, and there was a potential difference between them. Okay. We'll understand these things in the ongoing lecture. So object flow from this form, or some matter flowed from this point to this point when there is a potential difference. Okay. So it is the same. It is the same. So you can see that this thing also had a potential, this thing also had a potential, and object flowed until both have the same potential. Whenever they reach the same potential, the flow stopped. The flow stopped. Same is the case in an electric circuit. Okay. So let us consider that it is an electric circuit. It is connected to a battery. It is given as B. So electrons or positive charges flow from this side, or current this is flow from this side and comes to this side. So if I remove that battery, so what is current? Current is the flow of electrons, or the opposite flow of electrons. Okay. So when I remove this battery, let me draw an ammeter here. It is an ammeter. So if I remove that battery, does your ammeter show any readings? No, it won't show any reading, because there is no current. Okay. Electrons are everywhere, but there is no current. Electrons are present throughout, but there is no current. So it will show a reading whenever I fix a battery to it. Whenever I fix a battery to it. So what does it gives? It gives a potential difference. It gives a potential difference. So now electrons can flow and your ammeter can show a current. But why didn't the electrons flow when there was no battery? Because every electron here in every part of the circuit were at the same potential. And you know it very well. Matter do not flow when the potential is same. Okay, matters do not flow when the potential is same. They can only flow if there is a potential difference. So who gives a potential difference to the circuit? That is, the answer is a battery. A battery gives a potential difference to the circuit. It creates a potential difference between the positive terminal and the negative terminal, such that electrons flow from this side and goes to this side. This is higher potential and this is lower potential. Higher potential, and this side is lower potential, and this side is lower potential. You can see that objects. Here, what is the matter? In this case, your matter is electron. Matter is electron. So electrons flow from this side and come to this side. That means electrons flow from higher potential to lower potential. For electrons, this thing is lower potential because electron has a negative charge. Okay, you will get to know more about these things when we shall be learning more in this topic. So here in this case, matter is electron. Okay, in this case, matter is electron. But previously we said that electrons flows from this side to this side. That means it is going from lower potential to higher potential. No, it is going from its higher potential to its lower potential because it has a negative charge. Now, if it had positive charges, okay, if it had positive charges, then it will be flowing from this side to this side. For that case, it would act as a higher potential and it would act as a lower potential. So, charges go to from higher potential to lower potential and it also depends upon their nature. If it is a positive charge, then the higher potential is the positive pole of that battery and the lower potential is the negative pole of that battery. And if it is a negative charge, then the higher potential is the negative pole and the lower potential is the positive pole. So you get the idea that about electric potential and electric potential difference. We will study a bit more about these things. So so what is potential? It is a quantity that determines the flow of matter. Okay, what is a potential? Potential determines the flow of matter. Flow of matter. So matter can flow only if there is a potential difference. Okay, and this potential difference comes due to this potential. A potential determines the flow of matter. So what is an electric potential? So in electric potential, what is the matter? The matter is the charges. So electric potential determines the flow of these charges. Okay, so you can write the definition on your own that what is electric potential. Electric potential is the quantity that determines the flow of. So electric potential is the quantity that determines the flow of matter or the flow of matter between two bodies. Okay, and that matter is the charges in case of electricity. And we need to specify one more term in it, that is the direction. Electric potential. So a potential determines the flow of matter, determines the direction. Okay, the direction of flow of matter, the direction of flow of matter. So similarly, you can derive the definition of electric potential. So electric potential, write with me, electric potential is a quantity that determines the direction of flow of electric charges. If there are two bodies, electric charges between two bodies or bodies, you can write whatever you want. So if there are two bodies, this is one body and this is other body, so charge can flow from this side to this side only if, so let it have a negative charge, negative charge. Okay, we want that this negative charge flows from this side to this side. Okay, this body to this body. So we have to give it a positive potential. We have to give this body a positive potential because negative charges are attracted to the positive potential. Okay, or which means if it is a negative charged body, it has a higher potential for negative charges than this body, and in this case only it can flow from here to here if it has a lower potential for negative charges. Okay, so I assume that you have learned about electric potential. So why it is necessary that we learn about electric potential? Because in electrostatics we need to be determined about two things. What are those things? One is electric field and the other is electric potential. Okay, we have learned about electric field and now we shall be learning about electric potential. So in electrostatics it is an important point. Okay, you can note it. In electrostatics we need to determine two things. Okay, we need to determine two things. One is electric field, E, that is a vector quantity, and the other is electric potential. Electric potential. Okay, E and V, and it is denoted by V also. It is a scalar quantity because, and we don't give it an arrow. Give it an arrow. In electrostatic, we need to determine these things because if you know electric field, you can actually calculate this V, electric potential, and if you know this electric potential V, you can actually calculate electric potential E. They are interrelated to each other. So it becomes very necessary in some cases that we don't need to calculate electric field. Since it is a vector, it becomes very difficult when you are calculating complex things or the electric fields of complex distribution of charges. Okay, so in those cases you can actually calculate electric potential, which we shall be learning in the next classes, how to determine the potential of some charges. Since it is a scalar quantity, so it is easy to calculate. Since it is a scalar quantity, it is very easy to calculate, and from that electric field can be calculated by using a very small formula. Okay, now when you shall be learning more physics, like you after this plus 2 or 12th class, you have opted for PSc in physics honors or engineering, you will be learning about electromagnetic theory, or and in those books you will learn a very beautiful concept between electric field and electric potential. And before that you shall be learning some other things also, like some vector algebra in mathematical physics. In mathematical physics we determine that electric field of an electrostatic charge system, the curl of that field is zero. Okay, you cannot understand such things now. Some a year later, maybe perhaps you will understand those things. But up until then, just listen to these things. You don't need to memorize them. Okay, E is such a vector. E is a special vector. A special vector. Special vector. Why is it a special vector? Because its curl is zero. Okay, this is called curl. It is a del operator. That is, a del operator is what? It is del by del x I cap plus del by del y j cap plus del by del z k cap. Okay, just see it. Don't try to remember it. When we operate this thing on our electric field vector, it gives a result 0. And now the important thing is that if the curl of any vector is 0, then it should be gradient of some another scalar. Okay, it should be gradient of some another scalar. That is quite a funny part and an interesting part also, that if the curl of a vector is 0, then it should be the gradient of any other scalar. So E is equal to grad of a scalar. Okay. So what is a grad? It is also this thing. Okay. It is a cross product. Okay. This cross means cross product, and gradient will operate simply on a scalar. So scalar, it doesn't have some vector things. When this thing is operated over a scalar, it becomes a vector. So it is equal to E. What is that scalar in this case? In this case, that scalar is your electric potential V. In this case, that scalar is your electric potential V. So let me give you another thing, that E is a very special vector. Okay, electric field vector is a very special vector. Why so? Because its curl, okay, this thing and this thing are same, but in this thing it is a cross product and it is simply operated here. It is a cross product. The cross product of curl of this del operator with E vector is 0. Okay, if a del operator is cross product with E vector, it gives you 0. It is a, that's why it is a special function. And if it is 0, then it should be equal to the gradient of a scalar function. And in this case, this gradient is your V. And in this case, this gradient is your V. Okay. So it was crude concept. Try not to memorize it, but just know that, and it involves a lot of mathematical things. Okay, it involves a lot of mathematical things which is not good for you in this level. Just try to uh, take in the simple concept, not this. It is also a simple concept, but not for you because it involves a lot of calculus. Now, for now, you have to understand some part of that mathematical physics. So now let us skip these things. Okay, so let us come to the concept. It is a very simple concept. So we have learnt about electric potential. So let us come to electric potential from electric potential difference. Let us come to electric potential from electric potential difference. Us consider let us consider a charge Q is at O. Okay, it is a point O. You have a charge Q at this point, and let a line come out of it. It is a positive charge. Okay, so can you say the electric field line of this positive charge? It will go radially outward. Okay, I hope you remember these things. So let us consider 2 points here. This is B, this is A. You can take A here, you can take B here, whatever you want. Okay. So the potential associated with B, and the potential associated with A, B, A. Okay. The potential associated with B, and the potential associated with A should be B, A. Now consider a small charge Q prime. Okay, now consider a small charge Q prime. So, or Q naught, this is a very small charge. This is a very small charge. The charge should be so small that it does not affect the charge under consideration. Okay, it doesn't affect the charge under consideration. So, this is a positive charge. This is also a positive charge, a unit positive test charge. Let us have a unit positive test charge at A. B is a closure point. Okay. Between A and B, which is closer to Q or O, that is B is closer to Q. The potential associated with B is VB and the potential associated with A is VA. So you can actually see this is matter, this is our matter, it will only flow if VA and VB are different. It will only flow if VA and VB are different. Since it is a positive charge, it is a positive charge. So it to flow from this point to this point, the potential should be different. So or that means there should be a potential difference between these two points. Since it is a positive charge and the charge under consideration is also a positive charge, we have to work against it. We have to work against it because it is opposing this test charge. This charge is opposing this test charge. So in order to take it closer, you need to do work against this electrostatic repulsion. You need to do work against this electrostatic repulsion. So you can actually get that idea from the figure also, that Q is at point O and A and B are 2 points, whereas BA is the potential associated with point A and VB is the potential associated with point B. A test charge is at Q at A and it wants to go to B. It will go when we do some work against this electrostatic repulsion it exerts on this charge. Okay, so let us calculate that. So let us calculate the potential difference. If we name VB the potential difference, if V is the potential difference between these 2 points, then VB minus VA is equal to W by Q naught. W by Q naught. This is your potential difference. This quantity is your potential difference. What is W? W is the work done. Q naught is the test charge. Okay, Q naught is the test charge. So from this thing you can actually define it, the work done. Okay, so what is electric potential? It is the work done in moving a test charge between 2 points against the electrostatic forces. Okay, so you can see that Q naught is moving from A to B against electrostatic forces. Okay, and when you do work against electrostatic forces, that is your potential difference. Okay, so it is the work done per unit positive test charge against electrostatic forces. This is the simple definition. Okay, so let us define it. So that means let us write its statement. So you can actually see from this, it's VB minus VA. You are doing work from A to B, so you need to define its direction AB by Q naught. So what is the statement? So potential difference is the potential difference of an electric field. Are you seeing it, this point? Sorry, let me lower it a bit. Okay, so now let us write. So what is potential difference? Write like me. Potential difference. So what is potential difference between? So we are going to calculate potential difference between these 2 points. So you need to mention those points. Potential difference between 2 points. Okay, and these points are actually in an electric field of this source charge. This is a source charge between 2 points in an electric field. In an electric field is the amount of work done. Okay, follow. The statement is the amount of work done in moving a unit positive test charge. Okay, what is the unit positive test charge? This is Q naught. Test charge against electrostatic repulsion. Okay, repulsion or electrostatic forces, whatever you can write. So you have to go a little bit lower. So potential difference between 2 points in an electric field is the amount of work done. It is the amount of work done in moving a unit positive test charge from moving against electrostatic forces. Against electrostatic forces or electrostatic repulsion, whatever you can say. So what to which position you are moving this test charge from these 2 points. Okay, between these 2 points you can actually mention it here. Moving unit positive test charge between these points, okay, from one point to a right other, you can write electrostatic forces. Repulsion you can actually write, but forces, it is good now. Okay, so you get the definition. So a potential difference between 2 points, okay, it is actually a concept between 2 points in an electric field is the amount of work done in moving a unit positive test charge between these points against, okay, I against, you need to mention against electrostatic forces. So this is the simple definition of potential difference. Now we are going to determine its units and some definition and some more definition. So let us rub it. So I can actually rub the upper part of the lecture. It is not necessary now. So you can write is V, it at V or delta V, whatever you can. So V is equal to WAB by Q naught. Okay. So what is the unit of work? It is Joule. Okay. What is the unit of charge? It is Coulomb. Okay. So you can write Joule per Coulomb. Simply you can write volt. Simply you can write volt or volts. So what is the unit of electric potential difference? It is Joule per Coulomb or volts. So the unit of work is Joule, unit of charge is Coulomb. So the unit becomes Joule per Coulomb, and actually you can say volt. So it is Joule per Coulomb or volt. You can write volt, volts, anything else. So what is this term inspired from? From where this term is inspired? This is inspired from an Italian scientist, Alessandro Volta. He is a great scientist. He gave you the first battery. Okay, he gave you the first battery. As you know, earlier experiments on electricity was very limited because we did not have batteries. Up until then, when batteries were discovered, many scientists began to discover many laws, okay, many natural laws regarding electricity and magnetism. So you should be thankful for to Alessandro Volta to give us a battery. So V is equal to WAB by Q naught. It's Joule per Coulomb. So this is the unit. Okay. Now we can actually calculate V if V is 1 Joule per Coulomb. It is 1 Joule per 1 Coulomb. It will give you 1 volt. Okay. This will give you 1 volt. So what is 1 volt? So 1 volt, you can write the definition here. 1 volt is the potential difference between two points. So if the potential difference between point A and B is 1 volt, then what should be its definition? So 1 volt is the potential difference between 2 points in an electric field when, follow the definition, 1 joule of work is done to move the charge. What is the amount of charge? Move 1 coulomb of charge between those points against electrostatic forces. Electrostatic forces. This is the definition of 1 volt. You can write it according to you. Okay, you can write it according to you. Now some a little bit more concept remains. So I hope that you have understood this thing. Now let us jump to another thing. That means we take a to infinity. We take a to infinity. Okay, this is infinity. Draw it like it so that people understand that you are drawing infinity. Okay, a is infinitely is at an infinite distance, and for this condition, in at infinity, electric potential is zero. It is considered that electric potential is zero. So at this point, so what is VA? If A is at infinity, it is zero. It is zero. So VB minus VA gave you potential difference, and this thing will give you the electric potential at B, at the electric potential at B. So if we consider A to be at infinity, then the electric potential at A is zero, and at this thing only we get the potential at B. So what is the work done? So potential at B is defined as the amount of work done in moving a unit positive test charge from infinity to that point under consideration against electric forces in an electric field. So from this thing you can actually calculate electric potential at B. Electric potential at B. Potential at B. So what is electric potential at B? We assume A to be at infinity. Okay, to be at infinity. At infinity, VA is equal to 0. That is what we have considered. Okay. So since VA is 0, so potential difference between infinity and B is electric potential of B. Potential difference between B and infinity is the electric potential at B. So you understand the concept of electric potential. So VB is equal to work done by Q naught. So electric, this term is your electric potential. Electric potential at B is defined as the we have to consider electric potential at B a point in electric field. Okay, point in an electric field. It is a point in an electric field. Okay, is defined as the amount of work done in moving a unit positive test charge from infinity towards B against electrostatics forces. Electrostatic forces. So you have understood the concept of potential. Okay. First, I gave you the concept of potential difference, and we have reduced ourselves to the concept of electric potential. Okay. So it is the amount of work done in moving a unit positive test charge from infinity towards B against electrostatic forces. This is the potential at B. It has the same unit. It is also denoted by V. It has the same unit as volts, and it is the actual definition of electric potential. So at this point we end today's lecture. Let us see you tomorrow. Up until then, practice more. If you have any doubts, you can ask in the comment section of the video, and like our videos, subscribe us for more videos. So up until then, take care. Thank you.